Hi, this is Gary. In this tutorial we're covering quadratic equations. In front of me I have a y-axis in orange, and we also have an x-axis, and that's going to be in light green. Our first quadratic equation we're looking at is y equals x squared. Now I've listed a bunch of points that we can graph here, and the first point we have is if x equals 0, what does y equal? Well, if we plug in 0 for x, 0 squared is 0, so y equals 0. Now, if x equals 1, y is going to equal 1 because 1 squared is 1. If x is negative 1, y is going to equal 1. Negative 1 squared, or negative 1 times negative 1 is going to equal positive 1. If x is negative 2, y is going to equal 4, and that's because negative 2 times negative 2 is 4. Now, if x is 2, 2 times 2 is 4, so y is 4. And if x is 3, well, 3 times 3 is 9, or 3 squared is 9. And if you look at all these points we have here, and put them all together, we have a graph like this. Now I have another equation here, which is y equals negative x squared. And in this case, our numbers are actually going to be the exact same as the numbers for y equals x squared. If you take any one of these points, I'm going to take the bottom point here, and we plug in 3 for x. So y equals negative 3x squared. Well, negative 3 squared is negative 3 times negative 3, and that's going to equal 9. So essentially, for y equals negative x squared, it's going to be the same points on the graph as y equals x squared. And if we do that for x to the 4th or negative x to the 4th, it's going to graph the same way. It's just going to be steeper curves. The same goes for x to any even power or negative x to any even power, as far as like 6, 8, 10, 12, what have you. Now let's take a look at y equals x to the 3rd power. Now this is going to graph a little bit different than our x squared. What I have here is I have a list of points, and we'll take a look at each point on the graph here. Now let's say we plug in 0 for x. Well, 0 to the 3rd power is 0. And if we plug in 1 for x, well, 1 to the 3rd power, 1 times 1 times 1 is 1. Now if x equals 2, 2 times 2 is 4, but we're to the 3rd power, so 2 times 2 times 2 is 8. And if x equals 3, well, 3 to the 3rd power, well, 3 squared is 9, and then 9 times 3 is 27. So we got that point way up top. It's not even on the graph here. And then on the flip side, for the negative x values, if x equals negative 1, y is going to equal negative 1. And we get that from going, okay, negative 1 times negative 1 is 1. And then 1 times negative 1 is negative 1. And that's where we get our 1 value from. Also, for the same thing here, if x is negative 2, negative 2 to the 3rd power is going to be negative 2 times negative 2, which is 4, because the negative signs cancel out. And then 4 times negative 2 is going to be negative 8. So if x equals negative 2, y is going to equal negative 8. And if we graph all of these points that we've drawn right here, it looks like this. Now I have another equation here which says y equals negative x to the 3rd. And essentially, if you remember the points we had from y equals x to the third, well, our points are going to be a little bit different with negative x to the third. And by different, I mean that we are going to flip the value for y, or we're going to flip where y goes. So we'll y equals 0, it's going to be the same, but if y equals 1 on the blue graph, when we go to the light brown graph, y is going to equal -1. And conversely, we flip the values as we go on. And I'll take a look at this one right here. Let's say we have x equals 3. Well, our equation is going to be y equals -x to the third power. So if we have 3 to the third power, that's 27. And if we take -27 is going to be our answer for that, and that's where we get the -27. Conversely, if x is a negative value, for example, if x equals -2, well, -2 to the third power is going to be -2 times -2 is going to be 4, and then 4 times -2 is -8. But our x is negative, so the negative cancels out with the -8, and we end up getting y equals 8 for the value of x equals -2. And essentially we flip this here, and I'll show what that looks like on the graph here. Now the same principle holds for let's say x to the 5th or -x to the 5th, and x to the 7th, x to the 9th, x to the 11th, any odd numbers. We essentially graph those the same way. We just have steeper curves on the graph. And that essentially wraps up our tutorial for graphing quadratic equations. Thank you for watching.